Supply chain attacks and other application exploits are growing faster than ever. A big reason is because vulnerable CI/CD systems, service accounts, and microservices don't have an identity. No identity means no authentication and authorization when these services are used to maximize the blast radius of an attack. That's why Teleport created Machine ID. Machine ID delivers identity-based access and audit for infrastructure resources like servers and databases, CI/CD automation, service accounts, and custom code and applications such as microservices. By consolidating identity-based credentials for engineers and the application they write, Teleport closes the identity loophole that enables compromised infrastructure and code to be used in cyber attacks. Visit us at goteleport.com. Hello and welcome to another episode of Virtual Coffee with Ashish. And this time we're back in Melbourne. And hello to everyone who's coming online. And thank you for everyone who supported on the London meetup as well last week. So today we are continuing with our cloud native topic. And today we're talking about Kubernetes security best practice. And for this, I have someone special here. And I'm going to play the special song as well for the special one. So let's cue in the music. Hey. Thanks for coming in, Ian.
Yeah, thanks for having me.
Not a problem. It's always good to have, it's always good to have developer advocates coming in to talk about the space a lot more deeper level as well. So I'm glad you're here. And I've got a few more people coming online as well. Hey, Vineet, thanks for coming in, man. Hey, Rama, thanks for coming in. Sweet. All right. So I've got a few people coming in as well. So by the way, cheers. Thank you so much for getting a drink as well. I know you guys have a drink as well. It's like super early for you, so I appreciate that. What time is it for you at the moment?
Yeah, it's actually just after 7 a.m.
Here. Okay. So it's early, but no, I don't imagine it's your normal time. So I appreciate you getting into this, and I'll get straight into this as well. So for people who may not know you, Ian, what was your journey into your current role?
Yeah, sure. So I'm currently a developer advocate at Google Cloud. And I'm actually based here in Tokyo. So both of us are kind of in APAC at the moment. But I started out, I'm from the US originally, and I started out by going to college for computer science, and then did some work at some enterprise companies for early on. And then this was like in the Washington, D.C. area. And so I kind of decided to do something else, didn't want to go through the whole kind of, security, get a security clearance and do like government contracting kind of thing in DC. So, and I had a kind of hobby of like learning Japanese, and I thought that going to Japan would be kind of fun to do. And so I decided to do that. And then from there, I kind of started branching out, doing a little bit more like kind of community type of stuff. So I got involved with the local kind of Python developers and started to help build that community there. So we started like the Python JP conference and started kind of really gelling that community. And as I was doing that, like I kind of then, got involved early in like when App Engine got released. So like that was early on, like kind of a serverless product that supported Python. And so being a Python person, I was kind of involved early in like kind of working with people who are Python, wanting to learn App Engine and were learning Python for the first time, and things like that, because like they wanted to use App Engine, but App Engine only supported Python at that point. So like did a lot of that sort of thing. That's sort of how I got started in cloud. And then I kind of became more involved with like Google related tech. And then as Google Cloud became a big thing, became involved in that. And so I got tapped on the shoulder at one point to be to join the GA team at Google Cloud.
That's awesome. And because maybe that's a good segue to the technology that was kind of given by Google to the world as well, Kubernetes, I guess. So from people who may not know what Kubernetes is and may have just recently gotten introduced to cloud native, how do you describe Kubernetes to someone?
Right. So like there's a couple of things that you probably have to talk about when you talk about Kubernetes. Like first is containers, right? Like I think that sometimes people are when they're encountering Kubernetes, they're encountering containers themselves like for the first time. And so it's helpful to describe containers and what they are first, right? And like containers are a way, right, to package and run applications, and you kind of make use of your operating system features to give the application a kind of virtual environment. And this isn't using like virtualization, like you would say, like a VM, like virtual is a little bit overloaded. But this is a way of running the application so that it doesn't really see the other applications. It thinks it's the only thing that's running in that environment. And so it doesn't have like affect other applications. And so
Right.
that's kind of the main thing. You can set up a very specific environment for that application to run in that runs similarly no matter which machine you're going to run it on.
Oh,
And
that's
then
interesting. Yeah. Sorry. No,
go
I'll let you
ahead.
finish. Sorry.
And then I was going to move on to talking about Kubernetes, but
Yeah.
Kubernetes is
Go
kind
on.
of Kubernetes is a way of like essentially orchestrating those containers across a bunch of different machines, right? So like as you start wanting to build like web servers and services that scale, you want to be able to run that application on multiple machines. And Kubernetes gives you a lot of ways of making sure that the application is running, how many like making sure that the number of instances you want to run are running across the cluster, setting up the networking so that they can talk to each other, and doing other types of automation like auto scaling those applications, making sure that they restart when they crash and things like that.
So with the entire, so would it be, I don't want to use the word container orchestration management, but would that be kind of like a very, very high level of saying what it does?
Right, exactly. So like that's the word that folks use to talk about the things that or to describe the things that I mentioned, right? Like is orchestration, right? You orchestrate all of what the containers are doing. Like the word orchestration doesn't really describe exactly what happens, but it kind of gives you a good idea of like, Kubernetes is this orchestrator who's like, or that's controlling all of the containers in your cluster, right? Herding cats is another way that people describe it, right?
Yeah, and actually, herding cats is a good example as well. And I think the reason I kind of use that container orchestration thing is also because a lot of the times, and maybe some of the listeners who may be listening in, it's easy to kind of think that Kubernetes security is probably similar to container security, and kind of you mentioned that container is just one component of it as well. But are they quite similar in terms of how you would approach security for the two?
Right. Yeah. Like they're similar, but there are different kind of levels, right, of how you would approach security for something like Kubernetes. Because Kubernetes is like multiple levels, right? Like you can definitely think about the container itself and the security of the container itself, and then start like going up the stack from there. Like thinking about the networking, thinking about like the Kubernetes API server and all of the Kubernetes components that go into it. So for container security, you can think of like, there's a lot of different types of attack services, like what people would call attack services. So like, the container boundary itself. So like trying to make sure that if an application gets compromised or there's some malware in there, like that the malware isn't able to escape the container and go and hit other or affect other applications running on the same host. And then ideally, it can't jump from one host to another using some sort of other vulnerability. That's another boundary, right? And then there's obviously the attack surface of the container of Kubernetes itself. So like using the API server to, move to another host or to, do something there that it shouldn't be doing normally.
Right. And okay, because there's a lot more moving parts as well to Kubernetes and it's just container.
Right, exactly. There's a lot of different pieces, right? Like you can attack the Kubernetes API server. You can try to break out of the container and then use for example, like use the kubelets, the agent that's running on that particular machine to manage containers on that particular machine.
Yeah.
It also talks to the API server and has some credentials. And so you can think about like an attacker would try to take those credentials and then use its access that it gets to the API server to try to get the API server to do something that you don't really want it to do normally.
Right. So I guess some of our listeners may be interested also in one other aspect, because some of them work for consulting companies, and they obviously are always ask the question of how do you even start doing security for Kubernetes, right? So maybe what are some of the components of security that they should look at from a Kubernetes perspective when they talk to people who may have been doing it for the first time? How do you even describe where to start security? Because I think there's almost like two personas that you have to explain it to. One is the platform people who would be helping create that or deploy the Kubernetes, but then the other side is the security people themselves. And how does one, like, maybe a good place to start is what is the security components of Kubernetes that people should consider? And then you can go into a bit more into detail of it. But
sure. I mean, I can talk about a couple of things. Like, I mean, first, I think you would want to kind of understand like what containers are, right? Like if you're kind of getting started in the space or trying to understand Kubernetes security and kind of wrap your hand around it, like you kind of first need to understand what containers are and like what the kind of issues are with regard to just containers or that technology, right?
Right.
And we mentioned a couple of them, but like, that's kind of where you would start. And then you can kind of go to understanding Kubernetes itself, like what are the different components of it, right? Like there's a few major components, right? Like you have the API server, which is the normal thing that what you interact with when you're talking to a cluster. And then there's other components like the XAD server, which is where the state data is stored. There is the controller manager and the scheduler, which are also components that use the API server and are not normally used. They're kind of background components, but they're there at least and can be potential attack vectors. So you kind of need to be aware of them if you think about security. And then another major one is the kubelet that runs on each host, right? And that's what's controlling each host and is talking to the API server to understand like which things it needs to run on each on its particular host that it's running.
Right.
And so once you understand those kind of components, then you can start thinking about like, what type of attacks could happen. But there's kind of a number of things that Kubernetes itself gives you as features that you can think of as maybe components that will help you. Things like the security context, which is what is part of the API that you use to set different security settings for a particular running application. So things like you can make the root file system of your container like read only, so that an attacker can't like overwrite something in the container. You can do things like set setcomp or these like AppArmor or SE Linux type of policies on your container to like help harden it. So there's a number of different settings for the container itself there. And then there's other things like network policy, which is kind of a little bit of an add-on to Kubernetes, but that's another kind of core API that's part of Kubernetes that allows you to help kind of manage the attack surface at the network level.
Oh, okay. I like it how you approach it with the layers as well, like the network component, the host component. I'm assuming the runtime component as well. That's where your etcd kind of comes in. I think the interesting part over here for me is then, because there seems to be multiple kinds of deployment of Kubernetes as well. There are people who are, like, say, could be using GKE, the Google Cloud version.
Exactly.
But I may be a purist and I decide I'm just going to build Kubernetes from scratch, right? So would this change between them, or does it become easier if you're going to go to GKE kind of space?
I think it probably is a little bit easier if you're using managed service. Like, I think that most people, like, who are security professionals, like, recommend that people use managed service because, like, the people who are developing the managed service, know Kubernetes like pretty well, right? Like they like at Google, like we invented it essentially. So it's like we know it very well. Like we have lots and lots of developers who are actually working on it, like the core Kubernetes, like actually developing it. We have lots of people who are very well versed in it, and so we build a product that is like, has a lot of the security stuff built in. Like you don't really have to think about it as much.
Right.
For example, the API server is completely segmented from you, so like you don't have access to any of the real components that you might have to think about and secure. Things like XZD, things like the scheduler, things like that. Those are things that like you don't have access to, and so they're not things that you have to manage or secure at all yourself. But if you're running your own server, you definitely need to think about that, right? Like many folks, when they run their own server, they run an API, like they run a kubelet on their API server, for example, and then use that to run the Kubernetes components. So it's a little bit of a meta type of thing, but that means that you can kind of see the components in the Kubernetes API server. And if you somehow get control of the API server, you can then take control of or affect the things that are actually running Kubernetes itself. So XCD or or the scheduler or things like that, and do things like if you were somehow able to affect the scheduler or change the scheduler in some way, you could get it to, for example, schedule a pod, a specific type of pod onto another host that you don't have access to yet, and then allow it to run your malicious code there, and then essentially escape or escalate onto another host, for example. So like those are types of things you definitely need to start thinking about if you're like, especially if you're running Kubernetes yourself. Like you have to think much more about the actual Kubernetes components.
Right. And I think it's a pretty good one for people who maybe think you're deploying it, or maybe just curious about how someone deploys Kubernetes as well. To your point, the whole it is recommended to go down the managed path rather than the unmanaged and self-hosted path, because then you kind of have a lot more moving parts for security as well, right?
Right. That's exactly right. Right. Like, and you have a lot more tools as part of the platform usually, right? Like if you're on AWS or you're on GCP or you're on whatever like platform you happen to be on, right? There's a lot of tools like the IAM, right? Like the VPC networking features, right? Like all of those features like will help you to kind of secure your cluster that you may not have, right? If you're running it on-prem or on your own machines.
But then you're starting from scratch. If you do it self-hosted, you kind of have to build the network.
Exactly.
How do you do identity? How do you do even, to your point, network security, host security? Kind of just like the Pandora's box is open at that point in time. You just basically kind of shut it down.
Yeah, like how do you, like if you're going to use like another, like if you're on-prem and you want to use a cloud service, for example, right? Like you've got to give it some sort of like let's say like a service account key or something like that, or an API token or something that you have to put in your container in order to give it access to that server. And a lot of times those are long-lived tokens or tokens that don't refresh or anything like that. And so if they get stolen, your access, like the folks who stole it have access to that API forever. And so, there's some features like as part of GKE, like for example, like workload identity, which allows you to get like kind of much more short-lived tokens that you can use for accessing GCP APIs, for example, right? And so those type of features don't really exist or are very hard to replicate outside of a cloud platform or a hosted environment.
Yeah, unless you have like 100+ team just waiting just to deploy all these.
Yeah, you can definitely set it up, and there are components like if you're gonna set up Spiffy and all of those kind of identity components, and you can get it working in the right way, you can do that sort of thing. But it's very involved to get that done.
Yeah, and that's why maybe it's interesting also to point out, because I think in the CNCF realm, Kubernetes is still at least based on the reports that I've read, it's still the most active project as well, one of the most active projects, but it's also one of the most confusing projects as well, because there is a whole managed component and then there is a whole self-hosted component as well. And I think if you start adding layers like service mesh and all the other things, Istio and all that other thing that kind of comes in, like, maybe another part of the whole security thing is when someone is deploying a Kubernetes cluster, do they need all these other components like Istio and all the other stuff that we get people talk about? Do they need OPA? Do they need Istio? Or maybe are we better off answering the security thing first and then kind of going into some of this?
Yeah, I think that's like Istio and OPA are definitely things to look at and consider, right? Like but I think that they're not necessarily the first thing that you would consider.
Right.
So definitely, like when you are operating a Kubernetes at scale, at a much larger scale, you definitely want to be thinking about these particular features or these particular things. But there's a fairly large trade-off between like the overhead of running these and operating them, on top of, for the cost when you're doing a cost benefit analysis, for example. So like, there's a lot of overhead that you have to do to manage them, but you'll get these benefits, but you have this like kind of large cost, right? So if you're operating at scale, that benefit is much bigger for you, so it kind of balances out the cost. But if you're operating at a much smaller scale, the benefit is much less, but you still have a fairly high management cost, and so it doesn't really balance out quite as well in that case. But that said, like from a security standpoint, you do get a lot, right? Like Istio gives you identity, it gives you like management over your services and observability of services at things at a service level, right? Like you can say like this service talks to this service and this service talks to this service, and you can kind of see that like kind of graph of the services and how they talk to each other. You can see like you can set up policy for like which services can talk to which services, and they get strong identity, like essentially kind of cryptographic identity, so that they can't impersonate each other, for example, and kind of get around that policy that you set up. So that's one of the kind of major things that Istio gives you. But like if you're running like one or two services, it's not going to give you like a huge advantage. Whereas if you're running hundreds of services or something like that, you're going to get a huge advantage by using it. And the same thing kind of goes for. Go ahead.
No, sorry. I'll just let you finish because I was just going to ask a question.
No, I was kind of mostly finished there about OPA, but I was going to go talk about OPA, I guess. But
it's worthwhile calling out because I think where maybe I was going to get into the OPA space as well, but maybe where my question was going to kind of land on was with Kubernetes. To your point about different components, I think one thing to call out for people who may be listening in is that you don't need Istio to begin with. You don't need OPA to begin with, unless you're talking about large-scale deployments. Like if you have one project on Kubernetes cluster, probably it's an overkill to go for OPA, Istio, and everything else. Would that be right?
Right. Yeah, I mean that's exactly what I'm kind of trying to hint at. I think is that like if you're operating at a fairly small scale, you're running a couple services, you're not really going to get huge benefit out of it. But you will as you kind of get to managing large services, and if you're kind of as you start running hundreds of services or like 10 upwards of 100 services or something, you're going to really get a lot more benefit in that case.
And probably have a dedicated team for that, managing that as well, because that's a full-time job in itself.
Yeah, and that's what I was going to say about like OPA is that like it's something that like you set up policy. Like that OPA is essentially a thing that allows you to set up policy, like so that like when you deploy an application, OPA will check that application to make sure that it's got the security context and the security features set up before it allows it to be deployed. And so OPA is another thing that gives you a lot of benefit as you scale up and you have a lot more team members. So like it makes sure that everybody's on the same page, everybody's deploying services that have the baseline security features set up. But you're not going to get a lot of advantage out of that if you're just doing it yourself, like by yourself, right? Like you can kind of essentially police yourself when you're doing that. But
Yeah.
if you've got like a team of like 200 people, you can't be like policing everybody or like, checking to making sure like everybody's got, their security features and stuff set up. You want to be able to put like a little bit of a gatekeeping aspect to it before you deploy to production. And that's what Opa gives you. So that's like, once you start getting to a large team where it's hard to manage that, that's when kind of Opa gives you the value. But it doesn't really give you the value when you're like a really small team, if that makes sense.
That's a good segue into thinking more about when it's an individual starting to, I don't know, kick the tires of Kubernetes security. What would be, say, Kubernetes security 101 that they should be looking at to start off with? Maybe because we kind of spoke about earlier, we have different components. Container is just one component of it, and there's all these other API server and everything else, etcd, and everything else that goes into it. So maybe a good start to level the playing field for people who may be listening to you going, hey, Ian said it the right way. I feel like I want to start Kubernetes, or at least give it a shot. What are some of the low-hanging fruits that they can go for in the beginning of their first Kubernetes project?
Yeah, so like kind of the first things you might do. I mean, this is let's say like you've kind of researched containers. You kind of know what containers are and things like that. You kind of know the basics about like the Kubernetes API, like what sort of thing it's or how it works and how the different components in Kubernetes work. Then you can start thinking about like the biggest low-hanging fruit is really just checking out like what the container itself, like the security context features. So if you look at the security context API and you can like look at the reference API or the API reference like online, right? Like the Kubernetes API reference has like a little section on the security context and all of the fields that you can put in there. And so that's a good place to start, like just to look there and see what like sort of features are there. And some of the ones that I tell folks to turn on, like first is to, try to run your containers with a root file system that's read-only, for example. That's one of the features that's relatively easy to set up. Most containers aren't like overwriting stuff on disk everywhere, like all over the disk, right? So usually they have like one directory they need to write data to, or they use like a temporary directory to like write some temporary files to, but like they don't need access to write to the whole entire like file system. And so you can set up mount points for your the places you need to write to, and then make the rest read only so that it doesn't get overwritten by malware or other things. That's one thing that's relatively easy to set up. Another thing that is good to look into is to try to make your containers, or as a best practice, is to like try to make your containers run as non-root. So most containers run as root, a root user inside the container, right? And so what that does is like gives you a lot of flexibility because like it makes your containers run, have access to most things inside the container. And so you can do things like install packages and stuff like that, which is nice. But if somebody takes control of your container or there's some malware running in it, it essentially has access to the entire container itself. And then if it breaks out of the container, it can much more easily take over the host than if it was running as a normal Unix user. And so adding that in puts in like a pretty large hurdle for an attacker to have to get over before it can start taking over the whole host or escape the container. It makes it a lot harder for the host or for that attacker to do that. And so that's another thing that's like really a good best practice is doing that. That said, most containers that you're going to get, or most images that you're going to get from like Docker Hub, et cetera, are going to run as root. And so you can't necessarily do that for most of those images. You'll have to do some setting that up yourself or build the images yourself a lot of times. Some of the ones like the database ones do a decent, like the official ones like the Redis one, for example, or I think the MySQL one maybe does as well. Like run as a MySQL user or Redis user. And so that's getting better over time, but still most of them are running as root. I think those are the two kind of like really things that you can do that are fairly easy and will give you the most bang for the buck.
Yeah.
Another thing to look at is like network policy. Like if you have a Kubernetes cluster that is set up in a way that has a network policy, the feature enabled, if you're running it by yourself, like that's not necessarily something you're going to get right away. If you're using, say, like Calico for your network plugin or your network to set up your network, that will support network policy. But you need to make sure that your network plugin or your CNI implementation supports network policy. But network policy is another good one that allows you to set up kind of blocking, like to block network access between containers that don't necessarily need to talk to each other normally. And that can make it easy or harder for attackers to kind of probe your cluster and like figure out how to move from place to place. And generally, you can set that up without too much of a hassle or without like changing your application itself.
So maybe another way to, I guess, another component that I want to cover, because I think that those are good points. And I think people do need to be a bit more technical for this as well, right? So it's worthwhile calling out that if you are starting off doing Kubernetes, and someone would hear Ian going, yeah, talk about container host security and all that. There is a, what's it called? There's a technical component to it as well. But I think, is it hard to find information about this? Is that why a lot of people know about it? Or it's not documented? Or is there like a source where people can go to for these foundational pieces?
Yeah, I think that like the problem there is that like there's not really a single place for all of the Kubernetes security related stuff, right? Like there's like information about the security context, there's information about like network policy, there's information about like these different aspects of security, but there's not really like a one-stop shop for that online, I would say. Definitely some of the things you might want to check out are some of the books that have been written on it. So like there's a lot of colleagues out there, like Liz Rice is a very good resource for Kubernetes security related information. So like some of the books that she's written, one is called Container Security. I have it written down here actually, like Fundamentals, Technology Concepts that Protect Containerized Applications. But there's a, if you search for like Kubernetes, like container security book, right? Or you'll find it. And this is by Liz Rice. It's a good resource. There's another book called Hacking Kubernetes, which is more of a Kubernetes focus. And that's by Andrew Martin and Michael Hasenbloss. And Andrew is another really good resource for this type of Kubernetes security related content. And then there's a Kubernetes security book that's also written by Liz Rice and Michael Hasenbloss. So like that's, you see these names like pretty often, but Liz Rice, Michael Hasenbloss, Andrew Martin are like really good folks to kind of check out, follow online, read their books to kind of get a good understanding of the space.
Yeah, sweet. No, thank you for that. And I think one more thing I would like to cover towards the tail end of our thing is also that, Kubernetes deployment, you kind of have the two splits of deployments. We've kind of learned about how do we protect them, what are some of the components to think about from a security best practice as well. For people who may be listening in from I guess, who would have had the self-hosted one, and the advice over there is to try and move to the managed one, at least from what I hear, but best practice, because most of these best practices that you called out over here should be already covered by the managed provider. So if it's the GKE
Many
version,
of them, yes. Yeah, so like many of the things like actually setting up Kubernetes and making sure the cluster itself is secure are taken care of, right? Making sure that applications are secure is another kind of story. Like that's another a layer that doesn't necessarily get done automatically by running it on a managed service, but the value you're going to get from a managed service is making sure that the Kubernetes cluster itself is secure. So like, and the components itself are secure, and you're not going to have issues there. But that said, like, the managed services will also give you a lot more tools and features, like, in order to help you secure at the application layer. But because the application and the cloud provider doesn't necessarily know the components of your application, you're going to need to do a little bit of work there to make sure that that part is secure.
Yeah, no, sweet. No, that was pretty interesting, man. I think, and thanks so much for taking the time out for this as well, because I think most of the questions that I had around were, and most of the questions that we get around are these components as well. Where, how do you kind of, where do you even start? Because most people either have themselves walking into an environment where there's already a self-hosted Kubernetes, and then they're making a choice between self-hosted versus managed. They're also making choices between which component should I go for? Should I go for Kubernetes, and I should straight away go for Istio? Should I go for Envoy, or what am I really going for? Like, there's that confusing. Is there anything else that's normally you find when you talk to people about Kubernetes security, where people are misinformed, I guess, that you would call out?
Misinformed. I think that, like, most people, like, in general, like, from my experience, most people, like, have a fairly good understanding of a particular areas, right? Like, the problem is really kind of like what you don't know, right? Like, there's quite a lot of difficulty in trying to like understand the entire space, right? Like, and that's what makes it really difficult when you're running it yourself, because you need to know everything from like the like securing Linux, right? Like, you need to know about Linux and the like machines themselves and the operating system, making sure that that's patched and all of that stuff. And then before you even get to containers and Kubernetes, right? Like, you need to be like an expert at that, right? And so like that's the problem there, is like you need to know essentially everything, right? Like, you need to boil the ocean in order to kind of get a really secure Kubernetes cluster. And I think that if there's any misunderstandings, like the main one is like just a lack of understanding about like how much you actually have to know in order to kind of properly secure a container cluster, right? Like, every time you talk to somebody and maybe you mention something like about security, they're gonna be like, oh yeah, I didn't really think about that. Or like, and there's just so many things you have to kind of keep in your head. You have to keep it very broad, and you can't have too focused of a vision. You have to have a fairly broad, wide vision when you're thinking about it.
Yeah, cool, awesome. No, thanks so much for this. I think I personally got a lot of value from this as well, so I'm sure other people would have gotten as well. So towards the tail end, we normally have something called the fun section, which is basically 3 questions, just so people get to know more about you. And they're fairly straightforward. It's just to get to know you. So the first one being, what do you spend most time on when you're not working on Kubernetes or Python or Go? What's your favorite activity?
So I do a couple things, like, I do like to kind of play video games, like, on the computer. So I was kind of late to the party, but I started playing Among Us a little bit. If folks are familiar with that one, it's kind of a little bit fun and to play, and try to deceive people when you're the imposter and things like that. That's a little bit fun to do. Yeah, and like, being living in Japan and stuff like that, I still study Japanese, even though I've been here for a very long time and speak Japanese at a fairly high level. I still need to study that, and so that's another thing that I do that takes a good amount of time of my free time.
I can imagine. Next question. What is something that you're proud of but is not on your social media?
Something that I'm proud of that's not on my social media. That's a good question. I guess, like, I'm fairly proud of like the, I guess like how I guess I've managed life and the types of things that I've been able to provide for, people who are close to me, like my family, um, and essentially just kind of provide a good environment for people, for my family. So like, things like uh, buying a house and making sure that that's well funded and all of the kind of basic necessities. Um, just making sure that that's all in order is, I guess, I'm proud of. Yeah, I
Yeah,
suppose
no,
that's
that's a
maybe
great
one of the
answer,
major
man.
things.
And talking about basic necessities, food is also one of the basic necessity of people.
Yeah, of course. Yeah.
What is your favorite cuisine or food, or I guess that, or actually restaurant that you can recommend?
Um, I'm not really a restaurant person per se, but I would, in terms of cuisine, I really like. Uh, I think my favorite tends to be just Italian. That's kind of my go-to. I like a lot of pastas. I like a lot of tomato. I like a lot of sauces. Sauces are kind of like maybe the thing that I obsess over the most. That's kind of unique. I really like to mess with sauces, like you for pasta, but also just for um, kind of dipping sauces like that are used for like frying. So like things like in Asian cooking, like making those type of sauces that go into that, like those kind of
Nice.
thick soy sauce based ones. So yeah, like kind of trying to get sauces right is kind of one of the things that I obsess over a little bit, where I put a little bit more emphasis on when I'm cooking than other things.
That's making me hungry now. But thanks for sharing that as well, man.
Awesome.
Cool. Cool. That's pretty much what I had from a questions perspective. For people who may be listening to this and want to get in touch with you for, I guess, for Kubernetes and Kubernetes security, where can they find you and where can they reach out to you? Actually, sorry.
Yeah.
Before
So,
we do have a question. Sorry. There was a question asked. What would my security concern be if I were? What would my security concern if I decide to go beyond managed Kubernetes services and use something like GKE Autopilot?
okay. Yeah, so like that's a good question. Like GKE Autopilot gives you a little bit more of a managed service on top of Kubernetes, or like on top of GKE. So it handles a little bit more of the security. Like it provides like essentially a kind of policy layer on top of GKE. So it's a little bit like using OPA, or a little bit like using kind of a policy engine on top of using GKE. And it gives you, like, kind of by default, gives you a bunch of really good defaults, right, that it enforces. So like some of the things that I talked about in the security context, right, like it sets some slightly different defaults there, and that are more secure than the normal GKE. And so you actually have a little bit less security concerns, I would say. Like if you're using GKE Autopilot, like it's a little bit more of a secure environment.
Right.
But you still need to think about the networking parts of it, like and the like making sure that your cluster itself is secure. So like the API server is secure, and like that you have the right permissions set up on your API server, so that you don't give your applications access to the API server like more than they actually need to run. So like in that case, it really, you need to look at like the and this is true across all of Kubernetes, but it includes also Autopilot as well. But you need to kind of give your applications least privilege when it comes to the permissions that are allowed on the API server.
Awesome. And out of context, what is GKE Autopilot for people who may not know what it is?
So that's a good thing that I probably should have started with. But GKE Autopilot is essentially like a kind of more opinionated GKE, and so it gives you it sets up some slightly different defaults. So like as I mentioned, like you get it has a more strict kind of seccomp policy, so the application can't do quite as much as you can with in a normal cluster. From a security standpoint, that's the kind of some of the major differences. But it also like kind of removes the from a management's perspective, it removes the need to manage the nodes, right? So like a normal GKE cluster, you need to like specify a certain number of like nodes, and you can set up auto scaling on a GKE cluster, but you're essentially paying for the nodes in the GKE cluster.
Yeah.
And with GKE Auto-Pilot, like the nodes are essentially managed for you and they're hidden. And so the nodes exist, but they're essentially hidden for you. And you essentially only pay for the resources that are used by the pods in the cluster. It's a much more kind of a hybrid between GKE and a serverless kind of approach in terms of billing. And so from that perspective, it's much nicer for folks who want to do like kind of scaling that where their applications like scale up and down like fairly heavily, or they get a lot of application spikes or things like that.
Awesome. All right. Now, thanks for sharing that, and thanks for that question. I think I'm hoping.
Yeah, it's a great question.
Yeah, Aristides, I think, but I hope I didn't pronounce your name correctly, man. But thanks for the great question. Cool.
Yeah, thank you.
Right. So so going back to where can people find you? And I think once they have follow-up questions about this, where can they find you on social media?
Yeah, so I'm on Twitter. My Twitter handle is Ian M. Lewis. So like just add an M in the middle of my name.
I'll put that in the show notes as well, so people don't get lost.
Awesome. So that's my Twitter handle. I also have a blog on ianlewis.org, which is where my blog is. Haven't updated it too much recently, but I hope to do that a little bit more this year. And those are the kind of like the major places to find me.
Sounds good. I'll put them in.
You can also email me at ianmlewis@gmail.com, which is my kind of personal email.
Sounds good. I'll put the links for your website as well there, so people can actually get to that and to connect with you. But thank you so much for doing this. I appreciate you kind of waking up early for us and kind of spreading the word for Kubernetes security best practice as well. Thank you so much for doing that. And for everyone else who's listening, I'll see you tomorrow. We have another episode tomorrow, so I'll see you all tomorrow. But thanks so much for doing this, Ian, and I will talk to you soon, and maybe hopefully have you on the show again.
Yeah, absolutely. And thanks for doing this podcast. It's really a great podcast, and you've had a lot of great past guests as well. So I've really enjoyed kind of looking at your back catalog.
Yeah, thank you. Thanks so much. All right. Talk to you soon, and I'll talk to everyone else later on as well. See ya. Peace.